We can use the ideal gas law and link pressure, density, temperature, and molar mass. Here's how we can derive this equation from the ideal gas law. The number of moles can be replaced by mass divided by molar mass. See, this makes sense by looking at the units. Moles is equal to grams per mole. Mole equals mole. So step 1, PV equals mass over molar mass, RT. We can almost see that density shows up here. There's mass, and we have volume. So we can rearrange this. So we have mass over volume here, RT divided by molar mass. So we still have molar mass over here. We still have multiplying by RT. So these are equivalent. And this part right here, that's density. We can clean this up. Pressure is equal to density times gas constant times temperature divided by molar mass. Not necessary that you need to know how to do the derivation yourself, but using this equation, we will be able to figure out the density of a gas sample knowing some other information. Here is a density and molar mass problem that we can use this formula to help us find the density of a sample of ammonia gas. The scientist has a sample of ammonia, NH3, at standard temperature and pressure, that's 0 degrees Celsius and 1 atmosphere pressure. What is the density of the gas sample? So let's write out what we already know. Temperature is 0 degrees C. This is a gas law problem. We're dealing with gases, so we have to be in Kelvin. So that is 273.15. We also know the pressure, 1 atmosphere. We have R, our gas constant, 0.08206, and that is liters atmosphere per mole Kelvin units. What else do we know? We have temperature, we have R, we have P, molar mass. It doesn't tell us what the molar mass is, but we have the formula NH3. So we can use the periodic table, add up the mass of 1 nitrogen, 3 hydrogens to find out how many grams 1 mole of ammonia would be. So you need a periodic table. This is a well-worn mouse pad that is a periodic table because of course I have one of those. Okay, we have molar mass of nitrogen, 14.007. That's grams per 1 mole. We have 3 hydrogens, also grams in 1 mole. Can do some math here. Molar mass of ammonia, 17.031 grams per mole of ammonia. What's left is using this version of the ideal gas law. Pressure is 1 atmosphere. Density is what we're looking for. We have our gas constant. temperature. And we have our molar mass. And it's time to use our calculator. I'm going to simplify this as 1 atmosphere is equal to our density times our gas law multiplied by our temperature divided by our molar mass. That should be 1.316. And the units that are left over at this point are gram atmosphere per liter. To get density by itself, we have 1 atmosphere. We have to divide by this, and we should get density is equal to 0.759 units grams per liter of ammonia. The density of a substance is its mass divided by its volume. Because the volume of a gas varies with temperature and pressure, the density of a gas also varies with temperature and pressure. We're going to use the ideal gas law a little bit differently to figure out the density of silane, 2 liters of it, at standard temperature and pressure. So we'll go through a few steps using what we know about molar mass, moles, and the ideal gas law. The first thing we have to do is figure out the molar mass of the gas. So we don't need any equation, we just need the periodic table. Molar mass is equal to 28.086 plus 4 hydrogens So now we have the molar mass of silane. That's grams per mole. The next part, how many moles are in this sample? Well, to figure out moles, we have to use a gas law that has moles in it, which would be PV equals nRT, our ideal gas law. Pressure, it's given to us here, 1 atmosphere. We're at STP, standard temperature and pressure. Temperature, 0 degrees C. So we know pressure is 1 atmosphere. We know temperature is equal to 0 degrees C, which is 273.15 Kelvin. And we know R, our gas constant. Liters, atmospheres per mole Kelvin. So that means we've got 1 atmosphere. Volume is up here, should include that. N is what we're interested in. Running out of room. So 2 equals N times a number, R times our temperature. So N is equal to 2 divided by 22.41. Now we are looking for the mass of the gas in the sample. Well, what we do have is we have a molar mass, we have the mass per 1 mole, and we have the amount of moles. That's all we need to figure out the mass of what we do have. So we have the mass of our sample of silane. Now for the density of the gas in the sample. Density is equal to mass divided by volume. There we have it. The density of silane when we have 2 liters of it at standard temperature and pressure.